In this video, we're gonna talk about the problem 13 in the 4.5 chapter MOMEM. The function given by the picture has one local minimum and one local maximum. This function has a local minimum at blah 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 with a value and a local minimum at x equals to blah 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 with a value. So this question was asking about the local minimum and the local maximum. So to find that, first of all, we need to find the critical point of this equation. To find the first derivative, we need to first of all get to find the critical point, we need to use the first derivative. So we can just find the derivative of x that will equals to so to get a critical point, just let the first derivative of x equal to 0, which is we can do a further simplified to let it divide by 6 at the same time. And divided by -1. Now we just need to find the x value. We're gonna use the root equation for the quadratic equation, which is this will go equals to we're gonna know there are two roots of this equation. The x1 will equals to 7 and the x2 will equals to 1. So as far as we know, we already figured out the critical point. Right now we can draw a graph to do some value test. We can use the critical point to divide the whole x value into 3 different intervals. On the second line, we're gonna fill in the test value. And on the third line, we're gonna fill the form with the sign. And the fourth line will be the result. At this interval, we're gonna test x equals to 0. And we can know the result has a negative sign, so the graph is decreasing. Inside this interval, we're gonna test a value which is x equals to 2. The sign will be positive, and we can know the graph is increasing. And at this interval, we're gonna test at 10. The sign will be negative and will decreasing. So inside this, the first two interval, we can know the graph decreasing and first, then increasing, so the graph will look like this. It has a local minimum, and on the second set of the interval, the graph increasing at first, then go decreasing. It will look like this. So it has a local max value. So right now we just need to plug in the value into the original equation, which is fx. You're gonna get that f1 will equals to negative 13. The f2 will equals to 203. So when x equals to 1, it will has a value of negative 13. When x equals to 7, gonna has a value of with 203.